All right, suppose that a person's heart rate X minutes after vigorous exercise has stopped can be modeled using this quadratic equation. The output is beats per minute, and where the domain of F is from 0 to 12. So basically what that means is for somebody that is exercising between 0 and 12 minutes, this formula will predict their heart rate based on how many minutes it's been since they stopped exercising. So when we calculate F of 0, that means right when you finish exercising, this is your heart rate. So to get that value, I just plug 0 into our formula, and I get 190 beats per minute. Okay, which makes sense. Your heart rate would be high at the moment that you finished exercising. 3 minutes later, when I plug 3 into that quadratic, I get 137.5 beats per minute. So obviously you would assume that your heart rate is going to decrease as the amount of time increases that after you stopped exercising. All right, choose the correct interpretation. The rate is 190 beats per minute initially and about 180 or 138 beats per minute after 3. The rate is 138 beats initially and about 190 after 3. So we can see that A is the correct answer. Okay, part B. The times when a person's heart is between 150 beats per minute is about X minutes to X minutes. All right. So what we want to find here is between which two values. So if I did, let's see, that was A. This was part A. Now I'll do part B. Okay, we got to solve an inequality here, but we can use our calculator to do it. All right, we want to calculate when is this equation, this quadratic, when is it less than 150 but greater than 120. So between those two. All right. So if we were graphing this, which we're going to do next. All right, it's beats per minute. So that tells us that beats, the number of beats is your Y, and the time in minutes is your X. So we want to find, we're going to have a graph here where this is 120 and 150. And we want to find a time where our parabola is between those two values. All right, so we're going to take that and put it in our calculator, graph it. And so I'm going to go Y equals you initially type this in and go to graph it, chances are you're not going to see anything. All right, so you got to think a little bit about your window. Number one is time is always positive and beats per minute is always positive. So we really only need the first quadrant. Our X only goes up to 12 minutes, so probably we'll make our X go up to like 15 minutes. We know our beats per minute, we had a high of 190, so our Y is going to have to go at least to 190. So a good window might be something like make your Y max like, -2, your Y minimum, I'm sorry. Your Y max will go, 200, and we'll count by I guess tens, so we don't have too many tick marks. And then, whoops, I messed that up, guys. That should be, this is the X minimum, -2. Our X max only has to be 12. So we'll go out to 15, and we can just count by 1. Our Y minimum will make -2. Our Y maximum, 200, and we'll count by tens. Now we should get a better look at this graph. And there we go. All right, once I graphed it, then I graphed 2 horizontal lines to represent 120 beats and 150 beats per minute. On mine, the red line is 120 and the black line is 150. And then I graphed all 3 of those together. So what we want to do now is we want to figure out what these X coordinates are that belong with these different lines. Okay, so I want to find what the X coordinate is for that point right there. How many minutes that is. And it looks like it's going to be about 3 minutes. All right, but right now, the Y coordinate of that line is 150. That's beats per minute. And then I want to find the X coordinate, how many minutes until your heart rate was down to 120. So this point right here has a Y coordinate of 120. And I want to figure out what the time is. So we can use the intersect function on our calculator. All right, so I'm going to go second, calculate. I'm going to choose intersect, enter. All right, I want to find the intersection of the curve and the black line. So right now, my cursor is on the heart rate curve. So I'm going to hit enter. And right now it's on the 120. I want to move it up till it's on the 190 or the 150. So I just used my up arrow key to bump the cursor up to there. So that's the second curve I want it to look at, the red curve and the black curve. So I hit enter. Now I'm going to move my cursor where the intersection is, and I'm going to use that as my guess. And then hit enter. All right, so that gives me my first intersection. And it's about 2.2 minutes at 150. Now you're going to repeat that for the red curve, or the red line, and the blue curve. So second, calculate, intersect, enter. Okay, first curve, the heart rate. Second curve, it's now on the red line, 120. Enter. Move it to the intersection. Enter. And that's my second time. About 4.25 minutes, your heart rate is at 120. So this is 2.2 minutes since so remember, this is 0 minutes here. So after 2.2 minutes, your heart rate was at 150. Then from 2.2 to 4.25 minutes, your heart rate was somewhere between 150 and 120. So what I'm going to do now is take the difference of these two times, and that's going to tell me how long my heart rate was between 150 and 120. And that turns out to be about 2 minutes. Okay, 2.052. And our question says round these to the 1 decimal place. Okay, but let's see, I'm sorry, the question just says the times when a person's heart rate was between 120 and 150. All right, so the times were 2 point, you don't have to do any subtraction here, I guess. So 2.2 and 4.3 minutes. All right, the question's asking, what is the interval where f of x is greater than 0? So if I look at this drawing here, a sign chart that would go with that drawing would look like this. This is 2, this is 4. Okay, to the left of 2, my graph is positive. Between 2 and 4, the graph is below the x-axis, and then from 4 on, the graph is positive. So the intervals where the graph is greater than 0 are going to be the 2 outside intervals, these 2 that I'm highlighting in blue. So that would correspond to a solution set from negative infinity down to 2 and from 4 to positive infinity. All right, number 3, you're given a quadratic equation, and we have 2 points on it, which happen to be the x-intercepts. One of them is 4, 0, and then the other one is 8, 0. All right, and the question is, what's the x-coordinate of this graph, of the vertex? Well, the vertex is midway between these 2 points. So I want to find halfway between 4 and 8. So I'm going to add those up and divide by 2. So this halfway between there would be 6. Halfway between 4 and 8. So the x-coordinate of the vertex is going to be on that line. So its x-coordinate is going to be 6. Okay, Farmer Ed's got 60 feet of fence, wants to enclose a rectangular plot that borders on a river. Farmer Ed does not fence the side along the river. Find the length and the width of the plot that will maximize the area. Now, we did some of these in our homework assignments. The thing about this one is that you don't have to come up with these dimensions like you did before. All right, so we already know what these are. So if it's asking what width will maximize the area, well, the equation that's going to give us the area is going to be the length of, or the width of the rectangular plot times its length. So what we want to do is we want to find this maximum, or the maximum of this. Really, if you think about it, it's a parabola, okay, because it's got a squared term. X is going to be this length, and now the y coordinate is going to actually be the area. So when we plot this, this is going to be the width, and then the y value is actually going to be the area. Okay, so we can plot this on our calculator and find the vertex, or we could just use the vertex formula. Okay, so if I take this and I write it in order, negative 2x squared plus 60x. Okay, this is in general form. So I can get the x-coordinate of the vertex, which is going to give me the width, by doing the opposite of b divided by 2a. So b in our case is 60. A is negative 2. Okay, so the opposite of 60 divided by 2 times negative 2. gives me a width of 15. All right, so this part of the figure is going to be 15. All right, the length, okay, the labeled x in the figure is 15. And the other side now is going to be 60 minus 2 times 15, which is going to be 30. So the length is labeled 60 minus 2x, and it is 30 feet long. What's the largest area? Well, the y-coordinate in this case, the y-coordinate of the vertex is going to be the area. All right, so if I wanted to find the y-coordinate of the vertex, I'm going to plug 15 into my equation. So I got negative 2 times 15 squared plus 60 times 15. So the largest area, once I plug 15 in, that gives me my vertex. So the vertex of this would be 15 comma 400. And 400 is going to be the largest area that you can enclose, and that would be in square feet. And I believe on these, when you're typing these in, you have to put the label on each one of these. So the label for 1 would be in feet. The label for 2 is also in feet. And then the label on 3 is in square feet. Now you could do the same thing by graphing this equation and coming up with the vertex. And you can see I used the maximum function on the calculate menu, and I got x is 15, and it's hard to probably read, y is 450. Okay, solve the polynomial inequality, graph the solution on a number line. So we are going to take this and we want to find out what makes it first equal to 0. So I can factor it. The two numbers that multiply together to be 21 and add together to be negative 10 are going to be negative 3, negative 7. Okay, so on my sign chart, I'm going to put positive 3, positive 7. All right, now I'm going to pick a number from this interval. So, for example, a number that is to the left of 3, like 0. When I plug 0 into x minus 3 times x minus 7, I'm going to get negative 3 times negative 7. That's positive. Which then tells me this is negative and that's positive. Okay, the question is asking, in what intervals is this less than or equal to 0? So right there is where my function is less than or equal to 0. It's equal to 0 at 3 and 7. So in interval notation, that would be bracket 3, comma 7. Okay, which in this case would be, choice B, because of the brackets, not the parentheses. All right, a ball is thrown vertically upward with an initial velocity of 180 feet per second. The distance in s of the ball from the ground after t seconds is given by 180 minus 16t. At what time does the ball strike the ground? All right, so we threw a ball up, and at any time after that, this formula gives us how far it is above the ground. All right, so we want to do part A, when does it hit the ground? All right, so I could do this two ways. I can do it on my calculator and graphing, or I can do it algebraically, solving this equation. All right, so let's see, its initial height is 80 feet per second, distance in s, it's from the ground. All right, so when this thing hits the ground, s is going to be 0 because it's laying on the ground. So I could simply take this and just solve this equation by setting it equal to 0. So I can factor out a t, and I can, what two numbers go into 80 and 16? 8. So I'm going to factor out, since the leading term's a negative, I'm going to factor out a negative 8 and a t, and that's going to leave me with 2t minus 10. So I take each of these factors and I set them equal to 0. So one time would be t equals 0, and then my other time, this would be 10, add 10 to both sides, divide by 2, when t is equal to 5. So after 5 seconds, the ball is going to hit the ground. At 0 seconds, it hasn't been thrown yet, so it's on the ground. All right, is the ball more than 84 feet above the ground? The ball is more than 84 feet above the ground for the time t when, okay, so what times is it going to be at 84 feet? So I could do this two ways. One is I can take my equation and set it equal to 84. And then another way would be to graph it and then draw a line at 84 and take the information from the graph on the two different times. All right, so let's take a look at the graph when we do this. All right, so to figure out our window here, we know that the ball is going to hit the ground at 5 seconds. So x is our x-axis is our time. So for x, I don't need to go much further than 5 seconds. So I'll go to 10. Count by ones. Okay, we know it's going at least 84 feet. So I'm going to say, I don't know, maybe the y max is 100. So we'll do that, and we'll count by tens on the y-axis. Okay, let's see if we can see the whole graph. Yep, pretty good. Could probably go up a little bit higher. So I'm going to make my y max 110. Now what I'm going to do is graph a line at 84 feet. So I'm going to draw a horizontal line at 84. And there's my drawing. Of that line in the parabola, and that's going to give me the time in which it hits 84 feet. All right, so I'm going to go second, calculate, and I want to find the intersection of the blue curve, so it's on the curve, hit enter, the red line, enter, and I want to find this first intersection over here. Guess. And there's the coordinates of my intersection. This is going to be 1.5 okay, seconds, and the height is 84 feet. Okay, so this line is 1.5. All right, now I want to do it for the other one, the other intersection. So I go second, calculate, intersect, enter. Okay, red curve, or let's see, first curve, second curve, move it over to where it intersects. Enter. And that is 3.584. All right, so the question's asking, when is the ball more than 184 feet? So once it passes 1.5 seconds, it's going to be above 84. And until it reaches 3.5 seconds, and then it's going to fall below 84 feet. Okay, number 7, use the graph of the quadratic function to write its formula in vertex form. All right, so when we're looking at this graph here, we've got to get the vertex, which is HK, and we can just pull it off the graph. So let's see, each block is 1, so that's going to be -1, looks like 2, 3, 4, 5. -1, +5. All right, so this equation is going to look like this right now until I figure out what A is. H is -1 and K is 5. So we got H is -1, K is 5. Okay, the vertex of the graph is then -1, +5. All right, now to determine A, we're going to take our formula here and we're going to pick another point from this graph, like the y-intercept, which is 0, 2. And to get A, I'm going to substitute in 0, 2, and then for x and y, and then solve for A. All right, so if I do that, I'll end up with 2 is y, okay, that's just 1 squared, so that's just A. Take away 5, and I get A is -3. Okay, so A is -3, so now our equation is -3 x minus, let's see, it's x minus -1, which is going to make it x plus 1, squared plus 5. All right, consider the equation. Complete the following. Write the equation as A equals x squared plus bx plus c with A greater than 0. All right, so what that means is you're going to move the 81 to this side because you want to keep the coefficient on x squared a positive. So if all I'm doing is rearranging this and getting it equal to 0. So I'm adding 81. Okay, and the value of A right there is greater than 0 because it's 1. All right, so that's my first part. Now, calculate the discriminant. So my discriminant is going to be b squared. So b is negative 18 squared minus 4 times a, which is 1, times c, which is 81. So let's see, negative 18 squared, that's going to be positive. When you type in, if you're squaring a negative, it's got to be in parentheses. Otherwise, the answer, it'll give you a negative product. Okay, minus 4 times 1 times 18. Okay, that's 200 and, I'm sorry, I typed that in wrong. I think I said 18 and it's supposed to be 81. So let's clear that. Okay, it should be negative, whoops, clear again, parenthesis, negative 18 squared minus 4 times 81. And I get 0 for my discriminant. All right, determine the number of solutions. So if you remember, if a discriminant is equal to 0, it has 2 equal roots. That means the parabola just touches the x-axis. All right, so it has 2 equal roots, which is the same as saying, since they're equal, 1 real root. Okay, solve the equation, select the correct choice, fill in the boxes in your choice. All right, so this one is saying I'm going to solve this, which just means factor it or use the quadratic formula, and you're going to get your x values. So I'm going to get x squared minus 18x plus 81 equals to 0. I can graph this, or factor it, I'm sorry, into x minus 9, x minus 9. Okay, and then what makes these 0? Well, 9. And the other one is also 9. So they're 2 equal. Okay, we have this quadratic, 7x squared equals 1 minus x. And it's the first part of the question says, write the equation as ax squared plus bx plus c. So all this means is we're going to move everything to one side and set this equal to 0. It says you want a to be greater than 0. So what I want to do, this is my a, the 7. All right. I don't want to move the 7x squared over to the right side because then that would be negative. And this is saying leave it positive. So we're going to leave that there, and we're going to move the other two terms over to the left side. So add x, and now I got 7x squared plus x equals 1, and then subtract 1 from both sides, and now it's in the form that I want. 7x squared plus x minus 1 equals 0. All right, so that's our first part. All right, the second part is find the discriminant. So out of this, you know, our A is 7, B is 1. Okay, So I'm just going to do it over here. Get a little more space. Okay, so my A value is 7, my B value is 1, and C is -1. So B squared is going to be 1 squared minus 4 times A times C. So that's going to give me 1 plus 28 for a value of 29. All right, now, since this is greater than 0, it tells me that my equation is going to have 2 real solutions. Okay, because the discriminant is greater than 0. Alright, the next part says solve the equation and select the correct answer choice below. So we know it's going to have 2 real solutions, so we're going to end up getting 2 answers here. Alright, so for part C, we're just going to solve this. So when I look at this, I don't think I can factor it because I'd have to find 2 numbers that multiply together to be -7 and add together to be +1. Okay, so I'm going to go ahead and use the quadratic formula. Okay, so my B value is 1, so we're going to have -1 plus or minus square root. Now we already did the discriminant, that was 29, divided by 2 times 7, which is 14. Okay, so my answers are -1 plus or minus the square root of 29 over 14. Right? And that's the 2 solutions because you're going to have -1 plus this and -1 minus that radical. All right, a person standing at the top, person standing close to the edge on top of a 176-foot building throws the baseball vertically upward. The quadratic equation S of t equaling -16 t squared plus 64t plus 176, because you're on top of the building, models the ball's height above the ground. Okay, so this represents, this notation right here represents the height. All right. After how many seconds does the ball reach its maximum height? Well, that would be the same as finding the vertex. Okay, so the vertex is going to be the maximum. So to get the vertex, this is going to be t in seconds, and then this is going to be the highest value, the height. So I'm going to use my vertex formula because this is in standard notation. The vertex The x-coordinate of the vertex is the opposite of b divided by 2a. So that's going to be the opposite of 64 divided by 2 times negative 16. And that is 2. Okay. So what that means is at 2 seconds after it's been thrown, it's at its maximum height. Right. And there's our solution. You're just finding the x-coordinate of the vertex. And that's it. All right. Good luck on your tests. Equal or one real root, so x is equal to 9.